Video number 76 plus. A brief history of the cosmos. Hello. In 1988, the bestseller A Brief History of Time by Stephen Hawking was published, with the ambition of explaining to the general public the progress of modern cosmology. At that time, the vast majority of astrophysicists accepted the idea that time began with the Big Bang. Currently, the situation is a little less clear, and one day we will have to tackle the definition of time, whether the Big Bang is confirmed or disproved by observations from space telescopes. Until now, we have admitted a notion of time extending to the distant past, the notion that emerged empirically first from the observation of the stars, then more recently from oscillations, first mechanical, then electromagnetic. There is actually no really reasonable definition of time, the theory of relativity having, moreover, contributed to further obscuring an already vague concept. The object of this video is modest. It is a very succinct summary of the recent evolution of our knowledge about the cosmos. This evolution has been far from linear, and we need to be aware of this to avoid getting trapped in certainties that may be disproved later. In ancient times, the representation of the world was quite simple, as we recalled in the video dedicated to the Copernican revolution that initiated modern astronomy. The solar system, with its planets and asteroids, took on roughly its current form with the discovery of the dwarf planet Pluto in 1930. But subsequently, many giant asteroids, called planetoids, were discovered, and Pluto lost its planetary status in 2006. Currently, the planetoid Eris, with a highly elliptical orbit, is considered to be slightly more massive than Pluto. On the other hand, observations made from the Voyager probes, then from space telescopes, have significantly altered our perception of the giant planets. We will see that later. It was only in 1925 that we understood that the Milky Way was not the entirety of the cosmos. Some slightly blurred bright spots were identified as galaxies, some of which, like the Andromeda Galaxy, visible to the naked eye in good weather, are larger than the Milky Way. It was around the same time that the concept of supernova was discovered, the result of the extremely luminous explosion of very massive stars. These supernovae played a very important role as cosmic candles in determining distances on a cosmological scale. Here, we need to take a little step backwards. Between Giordano Bruno, who understood the nature of the stars as early as 1584, and the confirmation of this idea by Bessel in 1838, more than 250 years elapsed. The study of stars was then pursued systematically, their classification was gradually developed, to arrive at our current representations. With the discovery of other galaxies and their clusters, we entered modern cosmology headfirst, and it was around 1930 that all the major questions that motivate current explorations emerged: spectral redshift, missing mass, phantom light, etc. We therefore began studying the stars and other galaxies without fully understanding the solar system, which can become problematic when we want to make comparisons or extrapolations. And it was only in 1950, well after the fundamental work of Hubble and Zwicky on galaxies, that the Oort cloud was discovered, a complex object formed of two components, one in the form of a disk or flattened torus and the other spherical with a gigantic radius, around a light-year, likely containing billions of comets, the closest of which are confined to the Kuiper belt, knowledge of which is still very approximate. Returning to the planets, modern observation methods have made it possible to see, since the 1980s, that the giant planets have many more satellites than those that had been observed in the past, and that Saturn is not the only one with rings. Those of Jupiter, Uranus, and Neptune are much more discrete and have become visible with space telescopes. In 1995, the era of exoplanets began. Their existence, first conjectured, then established by the occultation method, was confirmed by observations from the Hubble telescope, then from the James Webb Space Telescope. Most of the observed exoplanets are obviously giant, the others being difficult to detect. Their list, summarized in the recent table shown on the screen, is growing day by day and their characteristics are highly variable. Finally, so-called extragalactic planets, that is, those located outside the Milky Way, have begun to be detected. Space telescopes, especially the most recent ones, now offer a glimpse of such a diversity of stars and their planets, that the particular nature of the solar system and our Earth becomes increasingly evident. And the mystery of the origin of life only grows with time.